Today we're going to look at prime factorisation. Prime factorisation involves writing a number as a product of prime numbers. So if we have a look at 12 here, we can write it as a product by expanding it out, and multiplying it by prime numbers. So we all know that 12 is equal to 4 times 3, but 4 isn't a prime number. 4 is equal to 2 times 2. 2 is a prime number though. So if we make that 2 times 2, then 2 times 2 times 3 is 12. And that's the prime factorisation of 12. We can sort of condense the 2 times 2 as well, because that's the square of 2, or 2 squared, and we have 2 squared times 3. So 2 squared is 4, times 3 is 12, and both 2 and 3 are prime numbers. We can use a great handy device called a prime factor tree to actually determine the prime factorisation. And that's where we start with the number we're trying to create the prime factorisation of at the top, and expand it down to multiply by any two numbers. So 12 we could have put down as multiplied by 3 and 4, but I chose 6 and 2. So if we've got here 12 is equal to 6 times 2. 2 is a prime number, we can stop there and circle it. 6 isn't a prime number though, so then we expand it as well. So expanding 6 as to be multiplied by two numbers, we can multiply 6 by 3 times 2. Notice it's not used for multiplying anything by 1, because that doesn't, we'd be left with 1 times 6 and it would be left with never ending 6 after 6 after 6. So 6 is 3 times 2. So both 3 and 2 are prime numbers, so we can circle them. So you can see here, 3 times 2 times 2 is 12, and that's what we've got up here. The lowest common multiple, LCM, of two numbers is the product of all of their primes. So multiplying all of the primes of all of the numbers for both of the numbers we're trying to find the lowest common multiple of, raised to their highest power. So if we've got 12 is, we know, 2 squared times 3, and 30 is 2 times 3 times 5, so they're all primes there, 2 times 3 times 5. The lowest common multiple of 12 and 30 is going to be 2 squared. Notice we've got 2 and 2 squared, but we need to raise them to the highest power. So the highest power is this one here, the 2 squared. So we've got 2 squared times 3, and then we've got the times 3 here from the 30 as well, but there's also the times 5 from the 30 there. So the LCM is 2 squared times 3 times 5, and that's 60. So the lowest common multiple of 12 and 30 is 60. The highest common factor of two numbers is the product of all of their common primes. So let's have a look at 12 and 30 again, and have a look for the highest common factor of both 12 and 30. We've got their prime factorisations here. The common primes that we have, we've got 2 here. Notice that we don't have, this one's got 2 squared, so that's 2 times 2. This one's only got 1 2. So there's only 1 2 that's in common. 2 squared isn't common to both of them, just the 1 2. So we've got 1 2 is common, and the 3 there is common as well. The 5 isn't common because the 12 doesn't have a multiply by 5. So the highest common factor of 12 and 30 is just 2 times 3, and that's 6. You can see it's a very easy way to determine the lowest common multiple and highest common factor of two numbers. Let's have a look at a first example of just creating a prime factorisation for 540, a much larger number. So we'll see how we can go with a prime factor tree. And you can see this prime factor tree is much larger than the smaller ones we've been looking at before. It shows you just how easy it is. So the first thing we can look for to divide, we need to see two numbers that make up 540. I always look for a number, a prime number, so that we only continue down one. Otherwise, the tree spreads out to a great degree. So here we can have 2 times 270. So you can easily see that it's divisible by 2 because it's an even number. All even numbers are divisible by 2. So 540 divided by 2 is 270. So you can see that we've split it into two numbers. 2 times 270 is 540. So now 2 is a prime, circle it, that's done. 270 once again, is divisible by 2, so we can divide it by 2. We get 2 times 135 is 270. Now we can't divide this one by 2 again. We can circle the 2 off because it's a prime. 135, not a prime because we can divide it by 5. Because the last number is a 5 or a 0, we can divide it by 5. So dividing it by 5, we get 5 times 27 is 135. 5 is a prime number, circle it. 27 isn't a prime. 27 is equal to 3 times 9. 9 is equal to 3 times 3. And you can see now we've gone to the end. We've got 2 primes at the end, so we can circle all of them. You can see here we've got 1, 2, 3, 4, 5, 6 prime numbers. So that means 540 is equal to 2 squared, because we've got 2 times 2, we've got 2 of them, times 3 cubed, because we've got 3 3's there, multiplied by 5. We've got the 1 5 there. So we could have done this a different way. We could have initially divided by 5 to start with, and then we would have been able to divide it a bit differently down. But the result will always be the same. It will be the prime factorisation. You still get the same primes regardless of what you decide to divide with to start with. Second example now, looking at finding the lowest common multiple and highest common factor of 105 and 90 using prime factorisation. So we should start by finding the prime factorisation of each of the numbers, and I did that using the prime factor tree. So 105 is equal to 5 times 21, 21 is equal to 3 times 7, they're all the prime, so I circled them. 90 is equal to 5 times 18, circle the 5, 18 is equal to 2 times 9, circle the 2, it's a prime. 9 isn't, 9 is equal to 3 times 3, circle the primes. So writing those out as a prime factorisation, 105 is equal to 3 times 5 times 7 there, and 90 is equal to 2 times 3 squared, because we've got 3 times 3, 3 times 3, times 5. So the lowest common multiple, we're going to be looking for all of the factors, all of the prime factors up to their highest power. So we've got a 2 here from the 90, multiplied by 3. They both have 3, but we're going to go to the highest power, 3 squared. Multiplied by 5, they both have 5, multiplied by 7 for the 7 there. Notice that we've only gone 5 to the 1 power because the highest power that both of the 5s are to there isn't any power there. So multiplying that out, we get the lowest common multiple of 105 and 90 is 630. The highest common factor of the two, look at all of the common factors, common prime factors that we have. 3 is a common prime factor. 3 squared isn't, 3 times 3 isn't. Notice because we've got 3 squared here, but it's not 3 squared there. So it's only one of the 3's multiplied by 5 because we've got a common 5 there. 2 isn't common, 2 is only with a prime factor of 90, and 7 isn't a common prime factor either because it's only for the 105. There isn't a common prime factor of 7 for 90. So here the common ones are 3 and 5, and so the highest common factor is 3 times 5, 15.